Hello everybody, this is your student Facebook meteorologist Sean Bagden here, and we're going to be talking about the potential severe weather threat for later today across the front range of the Rockies here, southern front range of the Rockies. We're talking down by Kim, Colorado, Aragon Pass, and out into northern and southern Kansas and Oklahoma here. We're going to talk about why they may introduce a slight risk, and we're going to break things down a little more simply than we would normally here. We're going to break down SKUTs, photographs a little more in depth. So first off, hold on. We're going to break things down from the upper levels to the lower levels here. Actually, 12Z soundings are out. We're going to be using KDDC there. Perfect. Okay, so here we go. We're going to start out this morning with our satellite picture right here. As you can see, right in that area, we're looking for convective development. We are free of clouds right now, right along the front range of the Rockies this morning. This is going to lead to strong destabilization of the atmosphere as we go through the day. Within the next 4 or 5 hours, we should start seeing convective bubbling here along the convergence zone the front range creates there. Also, we have this MCS moving through southern Kansas and northern Oklahoma here. This should drop down some moisture. As you can see, we already have some moisture here with the fog apparent on satellite imagery this morning. This should also help to increase moisture and dew points as we head into the afternoon hours as evaporation gets underway. That will also help increase the severe weather threat further off to the east as these storms march off in a line off to the east towards that northern Oklahoma, southern Kansas target area. So we're going to start with the upper levels and then drop down to the lower levels and soundings and photographs as we go. We're going to be using the 3K NAM as it resolves the mixed, it doesn't mix out the dew points as much, so we'll have a little more humidity to work with here. You can see the MCS, the upper level winds associated with the MCS right here. That is why it is being maintained as there's a maximum in wind shear along there. It should be weakening shortly as wind shear kind of trails off by the end, by the middle of Kansas there, and it's about entering that region as we speak. So we're going to head out to initiation time here, which should be around 21Z, pre-initiation time. Maybe we can go out to 0Z. 0Z is actually better out here. It's around 6-7 p.m. Okay, and here we go. This is where we're going to be seeing initiation right on the front range here as this maximum jet max at 500 millibars starts pushing through. That's going to locally increase our wind shear right along the front range of the Rockies there. As you can see, it's about 20 to 30 knots here in the southern Rockies. That's why we're expecting storms to initiate there. And then as you see, we continue to see the shear maximized out to about the eastern three quarters of Kansas and Oklahoma. That's why we're expecting a line of thunderstorms to blast across this area, especially since the shear is there for maintained convection all the way out to about Wichita, Kansas there, and Tulsa, Oklahoma. So we're going to closely watch how this area of shear evolves, as we could get a marginally severe line of thunderstorms here with winds gusting to 70 miles per hour. Also with the presence of steep lapse rates in the morning, KDDC sounding that'll lead to stronger updrafts, more instability, and potential for large hail here. Probably this on the order of ping pong balls as we head into that region. So now we are going to drop down to severe weather here. Going to be looking at EHI, Energy Helicity Index, which is a composite parameter here. And here you can kind of see the HERS kind of mixing out dew points a little much here, right along this boundary, although that may be the boundary of storms already starting to fire there. Let's go back to 21Z real quick. Yeah, that looks to be what's going on, because you can see we have this little pipe of wind shear getting advected back in here. Wind shear and instability is what this is a composite of, the Energy Helicity Index, and you can see there's a pipe right here in the southern Rockies, southern front range of the Rockies here, in excess of like 1.5. So this is where we're going to see the storm initiate right here, line of storms. Maybe seeing slight supercell characteristics early on, most likely multi-cells, as shear is a little bit low for supercells, maybe a transient supercell structure, but tornado threat will be low. We'll show you why as we head here. But then see, look at all this energy these storms have to deal with as they go out to the east. Much more favorable environment for maintaining an MCS out here into southwestern Kansas and northern Oklahoma here through the afternoon. We'll click on a sounding right in the middle of that energy there, and you can see we have the one minor problem we do have here is warm air aloft, which definitely decreases our instability here, but I believe as we head out towards the 0Z time frame, this will get eroded away a little bit. You can also see at the surface, we have kind of the development of an inverted V sounding developing there. The one problem I do see is the lack of dry air here. You have a lot of cloudiness early on, so that informs me that there's going to be a significant amount of non-surface based convection. It's going to be decoupled from the surface, as most of our instability is going to be above this inversion layer right here. So we are only going to be dealing with this amount of CAPE, which is still a pretty extreme amount of CAPE, or what, in excess of 1800 joules here. But we will not be able to work with this CAPE down here, which is the CAPE you need to get that really cauliflower convection, that strong convection, that surface-based convection that you can use to create tornadoes here. But another fun thing to see here, which you normally see with these Front Range Rockies events, is you see the split flow here, pretty much right up to the top of the Rockies at 1.5 kilometers here. You see flow backed out of the southeast, and then it quickly shifts. This is unusual to anywhere else you'd see when you're looking at wind shear here. And then once you get over to the top of the Rockies, that west to east flow is able to freely move up aloft, which greatly increases your wind shear. That is why it's very common to get severe weather on the Front Range of the Rockies this time of year, as you do have that potential for southeast flow events. And you can see we have marginal wind shear up to 33 knots or so, which is marginally conducive for supercells here. Although our upper level flow isn't strong, you have that directional change. So we can see since the winds are coming in together at about a, 100-degree angle, 151-degree angle here, it greatly increases the wind shear once that gets over 90 degrees. You don't really need speed shear to get potential tornadoes, although it is not quite strong enough today. Would not be surprised to see some very pretty mesocyclone pictures coming out of these storms today as they begin to mature. Maybe some nice shelf clouds as well. Also, we will look at a forecast photograph here, and you can clearly see our tornado threat here is pretty minimal, especially given this critical angle here is very subpar, we'll call it, for tornadic development here. That looks like a 1 or 2 degree critical angle. We're looking for somewhere more around 90 here. Well, actually, what is this? This is like, what, 60 degrees there, but nowhere close to 90, which we look for supercell thunderstorms. Also, you really don't have that helicity here, where you have this big cyclonically arced hodograph, where it kind of goes up to 30 knots and then flattens out and accelerates with height here. That's what we generally look for. This is more of a straight line wind sounding, as it shows wind is increasing with height, but not changing too much in direction. That's pretty much what we're seeing here. Yeah, that's what we're seeing here. So we are going to go out to, let's see, 0Z time frame here. And we're going to take a look at another sounding in this area here where these storms are going to be coming through. As you can see, we can easily maintain these storms with all this energy here out towards the Wichita area, Tulsa area, right out here. Extreme instability will be in place. So here we go. We're going to look at our new sounding here, and this is when we start to get out into the plains and we start to see these cranked photographs. Although these are not going to be all that interesting here, as we don't really have that strong flow aloft you would need. You have very odd looking photographs with the development of this, and again, we really don't mix out that low level stable air, so a lot of this is going to be elevated convection. That's when you get those really nice stratified shelf clouds there. So it's going to be a very good day for getting pictures of those. Very nice shelf cloud day in the, South Central Plains, with upwards of 4,000 joules of elevated Cape here. Again, we see this split flow here with easterlies at the surface, westerlies aloft. But again, we don't have that presence of this. When you see them, the winds veering like this aloft, you generally want to see increasing winds with height, unlike with that front range setup there, where you have winds that are going out of one direction up to the Rocky Mountain spine, and then out of a completely different direction above the spine there. So that's why we're not seeing much of a tornado threat with this. Even though this does say marginal tornado, I don't really see a chance of us getting tornadoes here, just because, again, we'd be looking for kind of the reverse of this photograph right here, where we'd see this 0 to 1 kilometer go straight up with a slight curve, and then the 1 to 3 kilometer shear going kind of straight across like that, showing changing in direction and height. And here we're really not getting much of a change in height, but we're getting a change in that direction, just not that change in wind speed that we really need. It is very stratiform winds aloft here, right around 25 knots, as you can see. Even lower in some cases here. Sometimes you get these weird little anomalies where it goes down to like 15, which is not good. You'd be looking for a flow around 50 knots aloft in this case if you're looking for a significant tornado outbreak here. So we're going to break down the forecast radar on the NAM, and then we'll go into the RAP analysis here this morning and break down the surface. So here is our 0Z forecast radar here. You can see why we have this marginal risk stretching all up and down the Rockies. You have all these separate EHI plumes here that are going to be blasting off. But we're going to be looking closely at these, as this could develop a bowed line segment this afternoon in association with that high amount of energy we have to deal with out here through the middle of the nighttime hours here, with that elevated instability, as these storms will die pretty quickly after sunset here, after that wind shear kind of fades away east of the Colorado border here. So we're going to see how this evolves. So we're going to go back a frame here real quick. Here's your initiation of storms right on the Front Range here. Palmer Divide down to Raton Pass here. These Raton Pass storms, again, are going to be the big players here. So going out to 3Z, we can clearly see this line of thunderstorms that it has initiating. It's a little spotty, but I believe this will be a little more filled in of an MCS as it translates off from the west to the east across northern Oklahoma and southern Kansas here. And then you can see it kind of makes a mess of this, but I believe this will be a very strong line of storms until it reaches out to the Wichita area, which is about right here, before it starts to weaken. Wouldn't be surprised to see a severe thunderstorm watch go out for this area right here this afternoon. If I was going to be chasing this afternoon, I'd definitely be starting out around the Kim, maybe Pueblo area, and then moving off to the east as we go to get those pictures of that shelf cloud developing, likely at sunset. Again, no real tornado threat today with these storms, as shear is just a little bit low for that, but definitely enough to allow for multicellular clusters and weak bowing line segments. So we'll see a convective line go across the area there. We're going to have a look now at the RAP analysis. If I can find it here. Here we go, mesoanalysis. Perfect. We're going to head down to these here central and southern plains states. One sec, I got to get a little further up here. There we go. All right, so this is the area we're going to be watching here. Currently, surface observations, again, these are very important when we're doing our forecasting here. You can already see these easterlies starting to pump in that moisture left behind by the MCS here, and also a boundary created by the MCS here with higher dew points to the south and lower dew points to the north in the mid and upper 60s here, and then the low 70s as you come down here. And these low 70s dews are going to get advected back. Also, very high dews here for this time of year, out in the high terrain of the Rockies here, out by Pueblo. Definitely very low cloud decks are going to be seen here, with temperatures only reaching the upper 70s to the low 80s, and dews in the mid to upper 70s here in this southeastern corner of Colorado. This will allow for some low LCLs and some very photogenic shelf clouds this afternoon. Also, plenty of moisture in place to decrease that wind threat. That's why we're only seeing a marginal wind threat this afternoon, instead of those days where it's in the 50s dews back here with 90-degree temperatures. That would end up creating a very strong inverted V sounding with dry air and evaporational cooling at the surface, and that would end up leading to a significant wind event out of this. But that's why we have not seen a slight risk out yet, is what my belief currently is on that. Alright, so here's what we're currently seeing. We're seeing a large amount of cap in place, very strong cap in place, gonna take till late afternoon to break this, but ample instability here. We're gonna see this greatly increase this afternoon as we steepen our lapse rates. You can already see the convective inhibition getting whittled away for the maintenance of that squall line out here in central Kansas and northern Oklahoma here, with extreme amounts of instability aloft, not surface-based instability, but aloft instability here, elevated instability in a pipe here of 3,500 joules of CAPE right in the area this MCS is going to be tracking. Then also another big thing to be looking at here is going to be this pipe of instability that's going to be getting advected back in on these easterlies to the just north of the Aragon Pass area here in Colorado. This is going to be what's going to help storms fire here off the Aragon Pass. We're going to be seeing 2,000 joules of CAPE just getting thrown into the mountains here on these easterly winds, weak easterlies, but still enough to get the job done. This was modeled on the NAM also earlier, so not surprised we're seeing this yet again. This is giving us confidence as to where the initiation point of these thunderstorms is going to be. This looks like right around the Pueblo area. So if I was going to be chasing, I'd be just to the east of Pueblo today, waiting for initiation. As you can see, 6 hours from now, convective initiation is pretty much a non-player, and we'll be seeing probably convective blow-ups starting to develop here right around the Pueblo, Colorado area in 6 hours, which is when? That's 4 p.m. Eastern, 2 p.m. Mountain Time out there. So around 2 p.m. we're going to start seeing convective initiation along the front range of the Rockies here, and likely by 3 p.m. seeing strong thunderstorms start to develop and move off to the east, and likely dive a little bit off to the south and east as they interact with stronger instability. They tend to feed off these instability boundaries, so we'll probably see them take an easterly track initially and then dive off to the south towards this stronger Cape Pool, and then slowly weaken as we can see this wind shear. Start to fade off as we head into the extreme eastern portions of Oklahoma here. It's going to kind of follow this axis of it and then kind of fade off once it moves south and east towards the Little Rock, Arkansas, or the Oklahoma-Arkansas border there. Also, speaking of the tornado threat, here's your storm relative helicity. Again, I'm not really seeing any real strong tornado threat this afternoon, as storm relative helicities will be generally below what we'd be looking for a potential tornado event here, with them hovering right around 100 to 50 values right here. We'd generally be looking for one of those 200 barbs here, but we're not really quite getting that. So again, we're going to be seeing strong lines of thunderstorms develop here just to the west of Pueblo on that instability axis, and then follow it as a marginally severe squall line, likely with a very nice shelf cloud moving from west to east till about Dodge City, and then slowly shifting south as it follows that strong axis of instability. We'll be going live again once convective initiation appears to be underway. Have a great day, everybody.